Let's go a little bit deeper specifically into hydrogen bonds. Again, hydrogen bonds are these interactions between nitrogen, oxygen, and fluorine. They will involve a hydrogen bond donor, which is the hydrogen atom itself, and then excited hydrogen bond acceptor, which is the electronegative element, either nitrogen, oxygen, or fluorine. So the OH here is the donor, the nitrogen is the acceptor, is the one with the lone pair that's accepting that hydrogen bond. And we'll find this, for example, in water. Very strong hydrogen bonds, they can form multiple hydrogen bonds. And that results in the very high boiling point of water for its size. Gives it a high surface tension, gives it a high boiling point. Based on its size, it's actually smaller than methane. Purely due to size, you would expect it to be a very, very low boiling point, less than methane. But because of its hydrogen bonds, it has a very high boiling point. This is a biologically very important molecule. Right? It dissolves biological molecules. It's used in a lot of biochemical reactions. And these hydrogen bonds really help it interact with a lot of our biological molecules. Let's look at some of these other intermolecular forces in action. Methane versus ethane versus propane. Okay. Methane, very small. So if I were to draw out methane for you, it would simply be CH4. Very small molecule, low molecular weight, no hydrogen bonds, no permanent dipoles, very weak London dispersion forces. So that corresponds to its expected very low boiling point. Ethane is slightly larger, still no hydrogen bonds, still no permanent dipoles, but the London dispersion forces do have a significant impact. Okay? They are non-negligible. Propane further increases the boiling point, again, just due to London dispersion forces. So even though you may have been left with the impression that hydrogen bonds are the strongest on the hierarchy, and then permanent dipoles, and then London dispersion forces, that's not necessarily always the case. It depends on the molecule itself. So if we look at something like methanol and ethanol, it would further get us deeper into the different boiling points and how the different intermolecular forces will participate in that. Okay? Methanol has a lower boiling point than ethanol. They both have hydrogen bonds, but the London dispersion forces do have an impact. So we can see that multiple types of hydrogen bonds can play a role in the boiling points and the intermolecular forces. Okay. So what that means for the MCAT is that it's actually really hard for them to be able to get away with asking you to predict the boiling point of a molecule. Suppose I have hydrogen chloride, hydrogen bromide, and hydrogen iodide. Let me first ask you the question, which of these is the most polar? So what do you think? Which of these molecules is the most polar? Okay, we talked about these periodic table trends already. We talked about them in general chemistry. You'll still need to know them here. Electronegativity increases as you go right and up on the periodic table. Fluorine is the most electronegative element. Francium is our least electronegative element. So it goes fluorine, chlorine, bromine, iodine. You will be able to pull out your periodic table here. And you can see that of the hydrogen halides that I have listed, HCl should be the most polar. Why? Because chlorine is the most electronegative. Hydrogen is the same in all of them. So the most polar one should be the greatest dipole. HCl is going to generate the biggest dipole here. Based on just the polarities of those molecules, we would expect that HCl because it's the most polar, would have the highest boiling point. But it doesn't. In fact, it has the lowest boiling point. And the reason for this is the sheer size. If you look at chlorine, bromine, and iodine, just the diatomic halide, Cl2, Br2, I2, these molecules are increasing in size. Iodine is much larger than chlorine. And that means that even though there's no polarity on these molecules, London dispersion forces effects are really big. So in the case of the hydrogen halides, HCl, HBr, and HI, the effect of the London dispersion forces outweighs the effect of the dipole, meaning HI has a higher boiling point. So again, on the exam, they can't just give you HBr, HCl, and HI and ask you which is going to have the highest boiling point. It's not a fair game question because there's too many variables here and they're conflicting. That does not mean, however, that you will not see questions about boiling point. So this is one of my favorite questions. Love this kind of question because of what it tells us about the MCAT. Go ahead and give this one a shot, and then we'll discuss. Okay, so the reason why I really like this question is because it gives us really good insight into how the exam is built. I've mentioned this before. It's important to remember that on the exam, there is one objectively correct answer, and there are three objectively incorrect answers. This goes across all sections as far as the writers are concerned. So it's obviously not as easy as pick this one, right? But as far as the writers are concerned, there's no gray area. So I'm sure we've all been in undergraduate courses where the professor doesn't really care about teaching and they write crappy exams, and frankly, a lot of their, especially multiple choice answers, are functionally indistinguishable. There's justifications behind, you could justify the multiple different answers. And then when you call them out on it because you picked the wrong one, then they say, oh, well, I kind of see that, but this is a better answer because of some reason or whatever. And they'll always be able to weasel their way out of it. Okay? That's not how the MCAT is structured. Every single question on the MCAT has been very rigorously worded, intentionally worded. And that's the other important thing, is that there's no accidents in terms of the information that they give you or the information that they hold back, or even why they're asking what they're asking. For this question, I could not have asked you about which one is going to have the highest boiling point. And the reason is because you can't answer that question. You don't know. But you do know which one is going to have the lowest boiling point. It's objectively the correct answer. We've talked about the odd one out before. This is another odd one out kind of question. So how does this fit into the odd one out discussion? Well, if we're being asked about boiling point, there's a bunch of different things that could be at hand. Could be London dispersion forces, could be permanent dipoles, could be hydrogen bonds. Well, there's no hydrogen bonds here. And the London dispersion forces for these molecules are all going to be basically the same. They will be slightly different because of the shape and their abilities to interact with each other, but the molecular weights are the same, the surface areas are roughly the same size. The dipoles are not the same, right? There is a polarity across the alkenes, across that double bond. So if I draw out the dipoles, my answer here is A. I'll justify that for you in a moment. If I draw out these dipoles, you can see that the dipole for this one looks a little bit like that. Dipole for this one looks a little bit like that. Dipole for this one looks a little bit like that. Now, and for A, there isn't any dipole at all. There's a completely nonpolar molecule. So this sort of brings together the odd one out kind of concept and what I was talking about initially. There is one objectively correct answer and three objectively incorrect answers. I asked you this question very purposefully. I can't ask you which one is going to have the highest boiling point because you don't know. You can't just look at these little blue areas arrows that you've drawn with no additional information and know which one's the biggest, there's no way for you to answer that question. So they won't ask you that on the exam. Okay? But they can ask you, and they would ask you, which is going to have the lowest boiling point, which is going to have the weakest dipole. Not because it's the smallest arrow of the arrows that I've drawn, I don't know which one's the biggest, and I don't know which one's the smallest, but because it's not going to have a dipole at all. It stands apart from the rest by some objectively determinable metric, right? It is objectively the correct answer. It stands apart from the rest. It's the odd one out. So, we can see again why. If I find myself trying to say, which one of these arrows is slightly smaller than the others, I have gone down the wrong rabbit hole. That is not going to lead me to the correct answer, right? Or if I'm trying to think about it some other terms that don't make it a black and white, this one is objectively correct, this one is objectively wrong, then I'm thinking about it on the wrong terms. I've gone down that wrong rabbit hole. So when you find yourself, and it's really important that you sort of have this self-awareness, when you find yourself trying to think about what makes this answer slightly better than the others, stop, because that's not going to help you identify it. You may get lucky and get the correct answer, right? You've got a 25% chance of getting it right. But you know right away when you start thinking that way that you were thinking about it on the wrong terms. So take that step back and figure out, what is this question really about? What is this asking me to do? And remember, the correct answer will stand apart from the incorrect answers like night and day if you're thinking about it on the right terms. It is objectively correct. That goes for numerical answers, right? We have to calculate something. And for word-based answers, the wrong answers are absolutely objectively wrong. And for more visual answers like this, we have to sort of interpret structures or graphs or things like that. Okay. Again, there's an auto and out question, and you'll see a lot of these kinds of questions in organic chemistry and elsewhere, of course.
For most students, and maybe you too, the CARS is the hardest section on the MCAT. It may feel like it's one of the few remaining obstacles between you and the medical school of your dreams. But as you try to prepare for the CARS, you find there is a never-ending stream of conflicting tips, strategies, and plans, none of which seem to actually help or show any results. If you feel frustrated, overwhelmed, or lost when it comes to the CARS, if you're looking for a CARS expert who has helped thousands of students achieve their MCAT CARS goals, then you found your solution. Testing Solutions MCAT CARS Bootcamp. Founded by Nick Zahner, a current medical student at Stanford with a master's degree in philosophy of religion from Harvard, Testing Solutions' approach to the CARS is revolutionary. Testing Solutions CARS Bootcamp provides day-by-day, step-by-step instruction that teaches you the techniques that produce ultra-high MCAT CARS scores. Instead of wasting your time with the needlessly complex filler that other companies try to sell you, Testing Solutions' approach to the CARS is based on the principle of minimum effective dosage. There's no wasted time, just the minimum amount of effort that is required to get you the results you want. With over 500 4.5-star reviews on Amazon, Testing Solutions CARS Bootcamp is the most trusted, proven, and effective CARS course available on the market today. You will have access to Testing Solutions' 180 meticulously designed CARS passages, the largest CARS practice library offered by any MCAT prep company in the country. Our passages are regularly rated by users on Amazon, Reddit, and SDN as the most accurate non-AAMC CARS practice passages available, consistently rated higher than Exam Crackers, the Princeton Review, Kaplan, and Next Step. Unlike some companies who prey on pre-medical student fears by charging outrageous amounts of money for their mediocre at best practice materials and courses, Testing Solutions will always charge a fair price for an amazing product. Because after all, we're not like the other test prep companies. We're aspiring doctors just like you, only a little further down the path. Let us help you do what we've already done. If you're not happy with your CARS Bootcamp for any reason, we offer a 100% money-back guarantee, no questions asked. You've got nothing to lose and the CARS score of your dreams to gain. Don't be one of the people who write us each week saying they wish they had found our MCAT CARS Bootcamp sooner. You don't have to struggle with the CARS any longer. Sign up and get started today.